So, what if the best way to teach an AI to be creative wasn't to push it forwards, but to teach it how to think backwards? We're about to dive into a pretty amazing breakthrough that basically flips the entire learning process on its head to solve one of AI's biggest, most stubborn problems.
You've probably seen this yourself, right? An AI can just demolish a calculus exam in a fraction of a second. But then you ask it to write a genuinely moving story and, well, it falls flat. What is going on there?
It all comes down to the kind of problem we're asking it to solve. See, AI is an absolute champion at what we call verifiable tasks, things where there is one single, provably correct answer, a ground truth. But creative writing? That's non-verifiable. There is no single right answer. There's just better, more original, more emotional. And that's where traditional AI just hits a brick wall.
Okay, so if the old methods aren't working, what are they and why exactly are they failing so badly? Let's take a quick look at the two main ways we've tried to teach AI advanced reasoning, and you'll see why they just aren't cut out for creativity.
First up, you've got reinforcement learning, or RL. The best way to think about this is like dropping an AI into a gigantic invisible maze. It just wanders around, blindly trying every single path, and eventually, if it stumbles on the exit, it gets a little treat, a reward. It's wildly inefficient, and for something like writing a story, there isn't one exit. The poor thing just gets lost forever.
The other big method is called instruction distillation. Now, sticking with our maze analogy, this is like giving the AI a map, a really good map drawn by a huge, powerful teacher AI. This works, kind of, but it's incredibly expensive to create that map, and the student AI can never, ever find a new path that the teacher didn't already know about. Its creativity is completely capped by its teacher. So what we're left with are these two flawed approaches. You've got RL, which is totally lost without a clear finish line, and distillation, which is super expensive and has a built-in creativity ceiling. This has been a massive bottleneck, especially for the smaller open-source models out there trying to learn how to do real creative thinking.
But what if we've been looking at this whole thing from the wrong direction? This is where the big breakthrough comes in. And honestly, it's such a brilliant, simple shift in perspective. What if, instead of starting at the beginning, we started at the end and worked our way back?
The old way, the forward way, is you give the AI a prompt. Something like, write a story about a lonely robot. And the AI just guesses. It tries to string together a thinking process, hoping that it eventually stumbles upon a good story. It's all just trial and error. The new idea completely flips that. You work backwards. You start with a known, fantastic answer, like a brilliant human-written story, and then you use computers to figure out the hidden, step-by-step thinking process that could have possibly led to that amazing result. The researchers call this REER, which stands for reverse engineered reasoning, and it's exactly what it sounds like. Instead of trying to build a thought process from scratch to get to a masterpiece, you reverse engineer the thought process from the masterpiece. Okay, so that sounds really cool in theory, but how does an AI actually pull this off? Let's break down the RER recipe. It's actually a super elegant little algorithm. It's this beautiful four-step loop. So first, it generates a really rough, kind of messy plan. Then it zooms in on little pieces of that plan and starts refining them, coming up with better, more detailed alternatives. Now, here's the really clever bit. It uses a score called perplexity to decide which new path is the best one. You can think of perplexity as a "how surprising is this" score. The less surprising the steps are in leading to that great final story, the better the score. And it just repeats this over and over, refining, scoring, improving, until it has a perfect thinking plan that completely explains how that great story came to be. Now, what's really amazing here is how well this scales. Using this exact method, the team created a brand new, totally open source dataset called Deep Writing 20K, and it contains 20,000 of these high-quality, reverse-engineered thinking trajectories. 20,000! So, the big question, does this actually work in the real world? To find out, the researchers took this new dataset and used it to train a model they called Deep Writer, and then they put it in the ring with the biggest names in the game. Just look at these numbers. Deep Writer is an 8 billion parameter model. In today's world, that's pretty small compared to the giants. But now look at the scores. On the long bench writing test, it scores a 91.28.
It doesn't just compete with GPT-4o and Claude 3.5, it actually beats them. For a model of this size to outperform the industry giants on a really complex creative task, I mean, that is just incredible.
But honestly, these scores are only telling you half the story. The really groundbreaking thing here is how the AI is getting these results. See, REER isn't just teaching it to spit out better answers. It's teaching it a fundamentally better, more human-like way of thinking.
If you look under the hood of most AIs trained the old way, their thought patterns are super rigid and formulaic. It's always, first I will do this, next I will do that, therefore. It's predictable, it's linear, it's robotic. DeepWriter's thought process, though, is something else entirely. It feels, well, human. It explores ideas, it backtracks, it corrects itself, it reflects. You can actually see it reasoning with phrases like, maybe I should, or wait, that's a bit too straightforward. It's not just running down a checklist, it's engaging in a genuinely dynamic, creative process. So this breakthrough isn't just about creating a better AI writer. It's about opening up a completely new path for AI development, and that has some huge implications for the entire field. So what's the big picture here? Well, first, RER gives us a powerful new way to teach AI, a third path that gets around the old limits of RL and distillation. This helps level the playing field, allowing smaller, open-source models to achieve world-class creative performance. And of course, that new dataset is going to fuel new research for years to come. And that brings us to one last really big thought. For so long, we've been focused on teaching AI what to think. But this research, this is about teaching AI how to think. So the question is, once an AI can truly master the process of creative reasoning all by itself, what becomes possible then?